In previous class, we started discussing Spark streaming, right? So let's create Spark streaming package, Spark streaming application. So we are creating some applications here, right? I'm creating one Spark streaming workspace, Spark streaming workspace. So let's create, yep, I think yesterday we created, right? Yep, we have already created. So in our Spark batch 2, so workspace, under workspace, I'm creating Spark streaming app. Okay, let's open this one, create new project, file, new project, Scala SBT project, click on next. Select the project. Under C drive, under users, in this user, under desktop, we have Spark quality thought directory. Under this, Spark and Scala. So we have batch 2, workspace, Spark streaming. Click on OK. Okay, here select 2.11.12. Click on finish in this window only. So it started creating project structure. Then parallelly, we need two dependencies. One is Spark core, because without creating Spark context, we cannot create any Spark application. So we need Spark core and Spark streaming. So let's go dependencies, Spark dependencies, Spark dependencies, SBT. Go to first link, click on up to Apache.Spark. Here you will see Spark core and you will see Spark streaming. We need these two dependencies. So 2.3.1 SBT dependency. Add this dependency, expand the Spark streaming app, click on build.sbt. Here paste this dependency, same as copy streaming dependency, copy this one and add this dependency in SBT file. Then click on import a project, so that it will import these two packages, these two jar files, and makes these jar files available to our application. Okay, so first application, what I'm doing in first application, we have one mission. So in this mission, assume this mission is 192.168.1.10 mission, 1.10 mission. In this mission, there is one network port called 12345. 12345. So there, in this port, one person entering some message. Hello, hi, how are you? How are you? Continuously in network port, in network port, one user is typing message, then through our Spark application. So this is our Spark streaming application, Spark streaming app 1, Spark streaming app 1. we are receiving this request. We are receiving this request. We are receiving this request. So this is our Spark application. In this, what we are doing, we are receiving and writing processing logic. So we are writing processing logic is find find words, find words or lines, find lines which has or not find, filter lines which has spark word. So that is our programming. Then write this result into console. Write this output into console. Write this output into console. Write output in console. Okay, this is our programming intention. So we are writing this application in our develop environment. So there is one system in network port. We are typing some messages. In that messages, we are filtering whether line has spark or not. If line has spark, then display that output on console. Okay, only read spark lines. If user enters any number of lines, continuously user is entering lines, then copy that lines into receive that lines, process that lines. In processing, find filter lines. If line contain spark, then write that one into console. So this is first application. First Spark application we are writing. First Spark streaming app. In first Spark streaming app, we are implementing this approach. Okay. So see, I have already implemented Spark streaming app. So let me create a package. My expand src main Scala. Right click on this Scala, new, your package, com.qt. In that qt, right click on this one. Here Scala class, select object, and this is Spark streaming app 1. Okay, let's copy already developed code, and after completing I'll explain what we written in this code. So in this application, first I'm creating Spark context, and in this Spark context I'm passing Spark context object to streaming context. Okay, so this is my streaming context. In this streaming context, I'm creating batches. Every 20 seconds, every 20 seconds, every 20 seconds, I will get batch. So batch gets big, batch gets created, then every 20 minutes, every 20, not 20 seconds, every 20 seconds, batch gets batch gets executed, batch gets executed or processed or processed. Okay, so this is our application. Every 20 seconds batch gets created, and after creating, every 20 seconds batch is executed. Example, here only will write example 7 o'clock 7 o'clock batch is started. So 7 o'clock is batch started. Then 7 o'clock at 20 seconds batch 1 is created, right? Batch 1 is created. Time batch batch processing. So first time there is no batch is executed, right? So until first batch creation, there is no batch is executed. 7 colon 20. One more batch is created, right? 720 to 740. There is batch 2 is created. Then this time batch 1 is processed, right? So parallel processing, batches are creating and batches are processing. In this way, processing is happening. Yes or no? In this way, processing is happen. Okay, batch is creating parallelly, processing is happen parallelly. So we return that application. So while creating Spark streaming context, I am passing Spark context and batch interval. What we call this batch interval? Sliding interval, right? Sliding interval. We call this terminology is sliding interval. Every 20 seconds, some data is created. That data is called batch, and every some time gap that batch is executed, we call that time gap is slide interval. So we are putting slide interval is 20 seconds. Okay, so I'm creating socket connection. I'm creating socket connection with our application to some network machine. Okay, socket connection. Spark streaming context dot socket text stream. IP address of that machine is 192.168.1.102 and port number is this one. So in this port, whoever types message, this application reads that message. So D stream is created. Every 20 seconds, D stream nothing but internally it will create series of RDDs. Internally, it will create series of RDDs. Internally, multiple RDDs are created. Okay, so multiple messages are entered in that socket. So internally, streams are creating. Then in that streams, filter X contains Spark. So if X contains Spark, then we are reading that data and we are creating D stream. Then if you want to save that one into specified location, or see, I want to save into same location. Same E drive or same location, then use just directory name, streaming output. That's it. Okay, in this output, or just give temporary directory. Instead of this one, give it temporary directory. In E drive, I created temp. E drive I created temp. Under temp I created streaming. So this is streaming data. Let's remove this one. Okay, E drive I created temp and streaming. So this is the output file name. In that output file, it will write return output. I'm printing some 10 lines as well as I'm writing data. Then when I say ssc.start, it will start application. And one more important point I need to cover is here, this application has receiving and processing, right? So we have to allocate two cores. We have to allocate two cores. Otherwise it may crash. So it is recommended to allocate to two cores. Okay. So this is our application. So this part is completed. This part is completed. Pending is start a mission with network port and write messages. Let's open VMware. In my mission, I have Ubuntu lab. Click on this Ubuntu because network socket network command is working in Ubuntu. CentOS network command nc command is not working. That's why I created one mission, Ubuntu mission. Let's start this Ubuntu mission. Let's enter into this mission. Yep, I don't want any update. So let's right click here and open terminal. See if config to find IP address of this mission. So it's saying 192.168.1.103. Okay, 103 is IP address. Let's start this application. Let's run this application. Yep, it's not saying streaming app 1 is not available. Let's go workspace. This is our application, right? Open cmd, type sbt. Okay, clean, compile. You can run from terminal or you can run from command prompt. Here in this command prompt also we can run. I will show you. Just type run. So it started running our application. Running com.qt.streaming app. So streaming application is started. Streaming application is started. It's saying there is no network port is running. There is no network port is running. Then what we can do is let's go how to do network in that application is so next one. Let's start streaming network command. So here what I'm doing, open this one. Here nc is a command. nc -l 12345 is a port number, right? So it started. Then where is our command? This is our command prompt, right? So let's type hello Spark. Hi Spark. Spark is a big data processing. So what is the error it is giving? Let's see. Issue communicating with the driver in heartbeat. Exception awaits some time. Okay, let's close here. Let's rerun from our application part. Let's execute this one. No class def found streaming context. Streaming application Scala 11. Let me see what is the error. Let's one time restart this machine. Let's start IntelliJ IDEA. Let's click on this Spark app. Right click on this one. Run Spark app 1. So still it's saying org data Spark streaming context. No class def found error. It should not be exist. Why it is giving error? Let me see and open another project which we created in batch 3. This one is perfect. Only one thing. Yep, Spark streaming API, right? Let's go build.sbt. Open this build.sbt. So here we are. Yep, perfect. I got the point why we are getting error. Let's open here. Open build.sbt. Here we added provided, right? We copied exactly, right? Remove this provided. What is provided means this jar file available until compilation time, not for runtime. So it's clearly saying this Spark streaming context is not available. When we are getting this error at runtime, not compile time, right? So compile time, because of this provided, this jar is not available runtime. Let's save this one. Then once again run this one. You cannot get that error. So it is started. Let's wait to start. Still we got error. Yep. Why we got error? We removed provided, but we did not, so it is internally processing, right? So let's wait to complete this processing. After processing, we cannot see that error. So if you want to update immediately, if you want to update anything immediately, if you want to update anything immediately, then go to SBT prompt. That's what I said clearly, Prasad. If you click put provided, jar file is available only until compilation time. Development time, they placed jar files in development location. So for compilation purposes only we are adding jar files to compile our programs. So wherever we are going to deploy this application, that location already jar files. That's why they added provided. For our purpose, we need jar file for compilation phase, runtime phase. So that's why we removed provided. Still we got error, right? Yep, we didn't run. Click on run. I think we cannot see after processing all the requests, we cannot see this error. Let's see. Yep, hello Spark, hi Spark. Spark is big data processing. Okay, then Spark, 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 Spark. Every 20 seconds batch is creating. Observe here. Every 20 seconds batch is creating. So Spark, Spark, Spark. If you observe, this is one time, right? This is called epoch time. Go to epoch time converter. Epoch converter. So click on this one. Open new duplicate tab. So place this time here. Click enter. So this is the time, and copy this epoch time and observe epoch time here. Enter. So what is the time is 16 16 hours 16 13 minutes 23 seconds, right? So 43 seconds batch, next batch is executed. So I think we copied the same thing. So let's take this one and see the result. We are unable to copy. Let's take this one and place here. It displaying here Friday, September 2018, 4:13:40 p.m. Previous one is 4:12:40. So let's go before this one, right? This one. Copy this one. Add here. Press enter. This is 4:13:20. Here 4:13:40. 4:13:40. Every 20 seconds it is creating batch, right? So every 20 seconds batch is creating. So this is called every 20 seconds batch is creating. So this will continuously waiting for the batch. Whenever you enter new batch, whenever data is generated, then it will read that batch. Hello Spark, how are you Spark? Spark. See, go here. So in this way, I'm entering hello, hello, but hello Spark, hi Spark. Only we get one word. Observe. Only hi Spark is executed. There is no hello hello because we are filtering. What is the side window? Come again. What is the slide window? Slide window and batch in this. What is slide interval? There is no window batch. So we discussed just slide interval, and we discussed batch. So the data which created, the data which created, in time gap. Time gap is called batch. So time gap we call it as slide interval. I don't know what is here. Slide interval is 20 seconds. Every 20 seconds it is, our application is going to connect to that network port. So it is continuously connecting every 20 seconds and gathering the data. Okay. Every 20 seconds it is trying to connect to that machine and gathering the data and creating batch. And next to it is waiting for 20 seconds and connecting system and reading the data. Okay. So this is called slide interval. This is called batch. This is called batch. This time is gap is called slide interval. Okay. So still it is continuing. When it is going to stop, we don't know. So if you want to use this one, instead of ssc dot await transfer, await, if you use ssc dot stop, what will happen? If you use ssc dot stop, our application, sorry, our application, Spark streaming application continuously reads and wait for the input. We need to stop Spark streaming application gracefully. ssc dot stop false and true. If you use this statement, what will happen? This application hits 2 times. First 20 seconds it will hit if there is no data, and again after 20 seconds it will hit that network port. If still data is not generated in network port, and it will stop our application. So it will wait, it will try 2 attempts. It will try 2 attempts. If you use ssc dot await termination, ssc dot await termination, it will still waiting for the data, continuously waiting for the data. If you don't want to wait, then use ssc dot stop false comma true. Okay. Yep, we saw one application, right? Let's stop this one. Second application we'll see. See, this is output is generator, right? Let's go E drive. let's go E drive, let's go temp directory. Here let's go streaming. So it is generated multiple streaming output directories. It is generated multiple streaming output directories. You got it right? Next, second Spark streaming directory. Second Spark streaming application. Second Spark streaming application. So we have a directory. See, this is my Hadoop cluster. Hadoop cluster. In this Hadoop cluster, there is one directory called slash qt. Under qt, there is a directory called any. Let's take reviews directory. Reviews directory. In this directory, what I'm saying, I'm keep on adding files. File 1, I'm adding file 2, file 2, I'm adding file 3. Like this, keep on I'm adding different files. Keep on I'm adding different files into this reviews directory. Then I'm writing Spark application, Spark streaming application, Spark streaming application, and in this Spark streaming application, I'm connecting this directory. I'm connecting this directory. This directory. Okay. If any file is loaded in this directory, I'm receiving that file. I'm receiving that file, and applying processing logic. Applying processing logic. Simply what I'm doing, I'm displaying file data on console. Data on console. In current application, what I'm doing, just reading that file and displaying file data on console. So whatever operation you want, we applied RDD operations, we applied SQL operations, right? You can convert to this D streams into that RDDs. So here in this application, what I'm going to do, see, every 10 seconds or 20 seconds, every 20 seconds or 10 seconds, connect to that input directory. So input directory name is reviews. Connect input directories, input directory, then read text file stream. Previously, ssc dot socket text stream. Socket text stream is used to read network port data. If you want to read file data, we use text file stream. Then we pass input directory path. Then we are reading that data and printing that data. So reading that data and printing that data. We are not doing anything. So this is our Spark application too. Let's take this one. So create Spark streaming app, Spark and Scala. So select this object, click on OK. Then copy this one. Okay, we are just creating the class objects. Okay, see reviews, right? And our file location is what? 192.168.103.80. Oh, Control Z. So in this cluster, let's start Cloudera mission. So this one is not required. Let's stop this one. Power up. Let's start Cloudera. Power on this virtual machine. One important to note here is Spark streaming application. Spark streaming application reads files from specified directory once application is started. Once application is started, reads files reads files after application, not once, after application started. So it will read files from specified directory after application started. uh, mm, Application started. It will not read files files it will not read old files. It will not read old files. Okay, it will read files only after you placed when application is started. It will not read old files. It will read new files when application is started. If you place any files into reviews directory, it will read only those files. Okay, so let Cloudera is started. Let's go cd putty. Here I have Cloudera, uh, Cloudera. Okay, so 192.168.173.1 173.1. So port number is this one. Save this one. Okay, let me see. So create a directory Hadoop fs hyphen mkdir Hadoop fs hyphen mkdir under root under qt reviews directory. So if qt is not available, use -p option. Okay, maybe Hadoop demands are running. So successfully created directory. Now what I am doing, cat greater than file 1. What I am doing, 1 comma 2 comma 3 4 comma 5 comma 6 7 comma 8 comma 9. So this is my file. Control D. Hadoop fs hyphen put. File name is file 1, and I want to place this file into under root under qt under reviews, right? I'm not placing any file directly. First I will start this application. So application is started. sorry, application is started. So batch is created. Let's place the file. So file is placed. Observe here. Yep. Internally it is creating RDDs. Observe. RDD7 is created and removed. Observe. Still it is trying to connect. Java.NET connection exception 192.168.173.1. So it is unable to connect that one. 8020 is failed. Why it is giving error? So it is unable to connect. It is unable to connect that machine. Let's see if config. It is 144 only. 144. So problem with our application. We changed 144. 144. Control S. Let's try to start this application once again. What I did is let's remove file to hello. Hi, how are you? Control D. Let's place file to. Let's place file to. Observe. So we got data, right? First file. Let's place CP file 1 to file 3. Yes, I want. Then put file 3. Observe. Once file 3 is placed, we got data, right? So our application continuously reading files from this directory, right? You got it, right? Hello? You understand, right? How streaming application is working? So next class, we will see some more important. Yep, you can, Prasad. Prasad question is, we want to store data in specified after processing result in HDFS. You can, Prasad. We can use Spark streaming context data save as text file. That's it. You can save data into wherever you want. That is our Spark streaming ability. So you can create connection. Wherever you want to store, you can store processed result. So currently we are displaying data in console. Here, if you want to store in RDBMS, then use connection, JDBC connection, store into RDBMS. If you want to store into Hive, wherever you want to store your data. That is the capability of our Spark application. There is no limit. No. If table is available, then we can store. See, if you want to connect RDBMS, again we have to go back to Spark SQL concepts. In Spark SQL, how do you connect? We use SQL context dot JDBC dot URL something, we pass everything, right? Use that option, save. Again we are going back, Prasad. So use Spark SQL statements to store this data into, convert this one into Spark SQL frame format, then store into database. That's it. Okay. So that's it for today. And mostly I'll finish this Spark streaming concepts in tomorrow class.